alkyl halides in a previous conversation. Let's talk more about the nomenclature and the uses of alkyl halides. So first of all, alkyl halides are compounds where a carbon group, an alkyl group that is, right, not an arryl or a vinyl or an allele, but an alkyl, which is a CH3 hybridized carbon, is bonded to a halide. Usually we're talking about chlorine, bromine, or iodine. Fluorine has got some weird properties because it's so small. So recall from section 4.2 the steps that we use to name a molecule. Number one, we identify the parent chain. Number two, we identify the substituents. Number three, we number everything, and then we assemble everything alphabetically. So the halide group is a key substituent, and we're going to name and we're going to locate it. So let's look at some examples. Look at this. 1, 2, 3, right? There's our propane. There's our parent compound. And so we have a chloro group on there. It's on the 2 carbon, so this is 2-chloropropane. All right, and you've seen how to name things like this before. So now we're just going to see that when we're naming a halide, we're going to call that chloro, that bromo, iodo, and fluoro for iodine and fluorine, respectively, right? So some simple compounds important to appreciate are used for their are called by their common names. This is not unusual. You've seen stuff like this before, like acetic acid and such. So, for example, the systematic name or the IUPAC name for this would be chloroeth. Let's see, yeah, 1, 2, right? There's our alkane, so that would be ethane, and then there's our halo, which is chloro, right? So it'd be chloroethane. 1 chloroethane, but since it's unambiguous which chlorine this goes to, we don't say 1 chloroethane, we just say chloroethane. However, it's not unusual to call this as an alkyl halide, right? So for ethyl chloride, same compound. Same thing over here. This would be dichloromethane, right? Because we've got just 1 carbon there, but we oftentimes call this methylene chloride. Let me bring this window down a little bit, just a minute here. Nope. Bring this window down just a little bit too big. There we go. Okay. So we've used Greek letters before, but it's I think it's valuable to appreciate again that the Greek letters are given as reference points to a primary feature of a molecule. For example, in an alkyl halide, this halo group is primary feature, so we would call that the alpha carbon. This is, again, the Greek letters are relative terms, right? So we would say this is alpha to the bromo group. This is beta to the bromo group. This is gamma to the bromo group, right? We've seen that before. And then we've also seen, we've also seen this kind of, man, my vocabulary is just nowhere today. So let me go over here, grab a marker, and pretend like I'm thinking. So here's a carbon. Here's a carbon that has 1 carbon-carbon bond, so it's a primary alkyl halide. Here's a carbon that has 2 carbon-carbon bonds, so it's a secondary alkyl halide. And here's a carbon that has 3 carbon-carbon bonds, so it's a tertiary alkyl halide. Halides appear in a wide variety of natural products and synthetic compounds, including insecticides, drugs, dyes, food additives, and many more. So the primary take-home for this conversation is how to name alkyl halides and to be advised that we're going to be using alkyl halides a great deal in organic chemistry, and I hope that you are comfortable with them very soon. All right, go practice.